Yeah, welcome. This is Mr. Walter, your science and technology teacher. I hope you are taking precautions because of this coronavirus that we are facing. Today, I want us to go through a topic known as energy. In the previous classes, you have discussed about this topic, and I believe you know the meaning of the word energy. So I'm going to begin by asking you a very simple question, and I'm going to get the answers from you, which says, what is energy? What is energy? Yes? Yes, thank you. Energy is the ability to do work. Energy is the ability to do work. For any work to be done, energy has to be applied. And when we say work, what do we really mean by this work? We only say that work is done when two things are involved. That is, work is done when two things are involved. And these are, one, we need to apply what we call force. We need to apply what we call force. And force is measured in what we call newtons, or N, capital N. Not only force is applied when work is done. For the work to be done, there must be distance that has to be moved. There have to be distance that has to be moved. And the distance is measured in what we call meters, that is small letter m. I can give you a very good example. I have a wall here. If I want to push it, this wall, if I try to push it, it cannot move. So if it does not move any distance, then we say there is no work that has been done there. But if I get something like a chair and try to drag it, move it from one place to another, it means I have done some work. So therefore, I mean, for the work to be done, there must be force that has to be applied. At the same time, it must involve what we call distance. If there is no distance, then count yourself to have done nothing, no work done. We go back to energy. We get to understand that we have different types of energy, which I would like you to tell me because you have learned them in your previous classes. Number one, thank you. Number one, we have what we call light energy. Light energy. The energy that enables us to see. The energy that enables us to observe things with our eyes. If it is dark, we are unable to see anything. But the moment there is light, we can be able to see anything. For example, right now, I can see there is a television there. There is a phone there. I can see a refrigerator there. Yes, all these things, we are able to see them because of our light energy. Another form of energy that we have, too, good, electrical energy. Electrical energy. Electrical energy is an energy which involves the flow of electrons in a good conductor of electricity. We use electricity at homes. That is, we have connections that are connected to the appliances that use electricity. So that energy can be able to flow through those conductors and then enable our electrical appliances to work. That is electrical energy. Number three, we have what we call magnetic energy. The energy called magnetic energy is the energy that has the ability to attract and repel magnetic materials. The magnetic materials that we talk about are, for example, things that are made up of iron, things made up of chromium, things made up of, yes, copper, no, aluminium, yes. So these are the magnetic materials that are able to be attracted by the magnetic energy. The fourth type of energy is called sound energy. The energy that is formed out of vibrations. I can talk, you hear me. Why? That is sound. You hear me because of the sound energy, through vibrations. So let's stop there. We shall look at other more types of energy because we really need to go back and look at the first type of energy that is called the light energy. Light energy. Yes. Can you remind me what we said light energy is? Yes? Very good. We said light energy is a form of energy that allows us to see and observe objects. We repeat it again. We say it's a form of energy. A form of energy that enables us to see. See what? Different objects. Without light, we cannot be able to see. Now, this light energy, therefore, it has different properties. That is the properties of light. What are these properties of light? What are they? What are they? Somebody tell me, what are these properties of light? We go and find out that the light that we see, number one, it can be reflected. It can be reflected. When we say it can be reflected, we mean it bounces off. Let's, for example, have a diagram of a mirror, and then we have a light ray that is coming from the source. When it strikes on this surface of a plane mirror, what is going to happen? The light ray is going to be reflected. It bounces back the shiny surface. It bounces back. So that is what we call the light can be reflected. Two, it can be refracted. Light can be refracted, meaning light bends as it passes through a different medium. There is a diagram that I want to draw here, and then you see what will happen. You can try this at home. Get a glass of water. Get your ruler. Then fill that glass of water with water. Dip your ruler into that water, a ruler or a pen or a pencil. Then observe what is going to happen. You will notice that that ruler will seem to be broken. It will bend. Why? Because the light can be refracted. The third property of light. Light travels in a straight line. It travels in a straight line. Sorry. A straight line. It travels in a straight line. Light cannot pass through a bent surface. That is why, if I have a pipe that is open from one side to the other, then I observe from this side, then I have the source of light on this side. What will happen here? You will see the light on the other side of the what? The pipe. Why? Because light travels in this straight line. But let's see, for example, we have a pipe which is bent like that. We have the source of light here, and then we observe from this side. Can you tell me what is going to happen? Will you be able to see the source of light? Hello? No? You? Yes. Who is correct now? I believe we say the light travels in a straight what? Line. So if the light comes and reaches here, do you think it is going to bend and come down there? No. So that one tells us that light must travel in a straight line. It cannot travel in a corner. So you will not be able to observe, not be able to see the source of light here because this pipe is not straight. The fourth property of light is light travels in all directions from the source. But remember, in a straight line. The fourth or the fifth property of light is light can be absorbed. So we say light is absorbed. So how many properties of light have we come up with today? Number one, we have said light can be reflected, meaning it bounces back or it bounces off when it strikes on a surface that is shining. Two, we have said light can be refracted, meaning that it can bend. It bends when it passes through a different medium. Three, light travels in a straight line from the source. And then the fourth, the light travels towards all directions. Lastly, light can be absorbed. Now, if we look at the first property of light, which talks about reflection, we are going to deal with now the properties of the images. How does reflection take place in different types of surfaces? We reserve that for the next lesson. I hope you have enjoyed it. When we meet next time, we shall see the different types of reflections and the different surfaces where reflection takes place. Have a nice day. Thank you very much.